All right, so let's get started. So this demo is set up so we can talk about the minus sign in this Faraday's law, which is called the Lenz's law. So the way the currents flow is such that they create a magnetic field which is opposite in direction to to the external magnetic field that we have here. So what we have here is a setup which will try to illustrate the Lenz's law, that the magnets will this is an electromagnet, okay? And here we have a loop. This is a complete loop, and this one here has a little slit in it, right? So when you have a complete loop, and I turn the magnet on by pushing this, you can see that the change in flux created by this magnetic field as I turn it on, the magnetic field sets up, so the field lines are coming out. And when they're coming out, it will induce a current through this loop, and the current in the loop creates a magnetic field, and that magnetic field which is created will be in such a way that it will oppose the change in flux. That's what that minus sign is, oppose the change in flux. So let's see, if it opposes the change in flux, it should fly. And see, it flies off. Whereas if I put this ring with a little slit on it, nothing happens, right? So it's critical, there it goes, it's critical that it is a loop. So we're going to have fun throwing things around. So let me pick these up. We're actually going to do one more little thing. So we can extend the magnetic field further using this iron core, as we call it. So let's put the iron core on top of this, and we'll put this ring, and let's see what happens. What the iron core is doing is focusing the magnetic field lines. So these magnetic field lines are focused into the thing, so they're all in there. So as the flux increases, you see the ring fly off, right? There you go. Now let's do, this is Badger land, so we overdo everything. So we'll cool this down and decrease the resistance of that aluminum rings. So let's keep it cooled down. So let's see what happens. Now what we are doing is pouring liquid nitrogen into the ring. So the ring is now getting cold, close to the temperature of the liquid nitrogen, the way it should be in winters in Madison. So there you go, let it cool down a little bit more. After it cools down, we'll put the ring on it, and now what we have is larger current in here because the resistance of this aluminum ring has reduced, right? So let's put the ring on it. Well, the class is over, but you can stay for a little bit longer. So now the currents will be higher, and there it goes, flies. Try to get it back. It's cold. But we want to make it even cooler. All right.
Let them see how high it gets.
Yeah. Let's see how high it gets. There's the ring. It's cold. All right, let's hit the ceiling, right? Well, not quite, but we made it almost there. All right, that's good enough. So the